If you've taken pre-calculus before, you can understand the solution to this problem. Feel free to give it a shot and keep watching to see the solution.
Okay, here's how to do it. So we've got two very similar expressions here, and what's different? Well, if I expand the first expression, what do I get? So if I expand this, I'm going to get 1 plus sine t plus cosine t plus sine t times cosine t is equal to 5/4. What would the second one be? The second expression is going to be 1 minus sine t minus cosine t plus sine t times cosine t. Okay, now what's different when we compare this and this? The only thing that changes is this. Okay, so if I say sine t plus cosine t is equal to x, what would this expression be equal to in terms of x? It'd be equal to 5/4 minus 2x. Okay. So what we really need to look for here is x. Okay, so how do we find x? Well, if we're assigning a variable for the sum of sine t and cosine t, we might as well assign a variable for the product. So from the first equation, what can we say about x and y? From the first equation, we get that 1 plus x plus y equals 5/4. Okay, so I can subtract 1 from both sides of this equation and get x plus y is equal to 1/4. Now, we want to get x. So how do we do that? Well, it would really help if we had another equation with x and y. Because if we have two equations, then we have a system of equations. And if we have a system of equations, then we can solve for x, plug it into here, and get the answer to our problem. So we're looking for another equation that has x and y in it. How do we find that? Well, what happens if I square x? So x squared is equal to, so if I square this expression, it's going to be sine squared t plus 2 times sine t times cosine t plus cosine squared t. Okay, and what's sine squared t plus cosine squared t? That's going to be equal to 1. And we assigned a variable for sine t times cosine t. What was that variable? It was y. So we've got x squared is equal to 1 plus 2y. So that's our second equation. And now we can solve the problem. So when solving this system of equations, do we want to solve for x or do we want to solve for y? So we want to solve for x. So we're going to be strategic about how we solve this. We are going to use substitution, but get rid of this y here. So how do we do that? I'm going to get y by itself here first. So x squared minus 1/2 equals y. And now I'm going to go into this equation and change y to this. Okay, so we've got x plus x squared minus 1 over 2 is equal to 1/4. And now we can solve for x. I don't like fractions, so let's get rid of it. How do we get rid of the fractions here? Well, we can multiply the entire equation by 4. Okay, and if we simplify this, we're going to get 2x squared plus 4x minus 3 equals 0. So we can solve this quadratic, get x, plug it into here, and then get our answer. So how do we solve this quadratic? We can use the quadratic formula. Okay, so it's going to be negative b plus or minus square root of b squared, so 4 squared, minus 4 times a times c over 2 times a. Okay, so this is going to be negative 4 plus or minus root 40 over 4, and that's going to be equal to negative 1 plus or minus root 10 over 2. So these are the two possible values for x. But what does the problem say about m, n, and k? M, n, and k are positive integers, and they want us to find k plus m plus n. Okay. So I think we can plug in both x values into here and see which one works for this. Let's go ahead and do that. So 5 over 4 minus 2 times x, which is, okay, I'll plug in negative 1 plus root 10 over 2. And then we've got 5 over 4 minus 2 times negative 1 minus root 10 over 2. Okay, so this first one's going to be equal to 13 over 4 minus root 10, and the second one is going to be 13 over 4 plus root 10. So which one is it going to be? It's going to be this one. So m is going to be 13, n is going to be 4, and k is going to be 10. So k plus m plus n is going to be equal to 10 plus 13 plus 4, which is going to be 27. This is your answer.